Hey, what's up guys? In this video, we're going to walk through this Leetcode for number 46, permutations. So we are given an array of numbers of distinct integers, and we need to return all the possible permutations. And we can return the answer in any order. So take a look at this example, 1, 2, 3. And one permutation would be 1, 2, 3, just itself. Second one would be 1, 3, 2. And the third one is the 2, 3, 1. So the 2 comes first, and then 1 comes second, and 3 comes after. And the number of possible permutation, n factorial, n being the number of elements. For example, for this case in here, we have 3 elements. The number of possible permutation will be 3 factorial. That is being 3 times 2 times 1. Because the first spot, we have 3 choices. After we have chosen the number for the first spot, and then we have n minus 1 choice for the second spot, and then n minus 2 for the third spot. Again, in this case, would be we have 3 choices in the first spot, 2 choices in the second spot, and 1 choice for the third spot. So 3 times 2 times 1. In this case, it will be 2 factorial and 1 factorial. This question was very popular. It was asked by these big names, and it has more than almost 7,000 likes as of July 2021. So we will solve this question by using a recursive function. Just like any other recursive function, first we need to have a termination condition where if the given list, the length of the given list only has 1 element, and then we will terminate the recursion function, and then we will append the result to the answer list, which we will return at the end of the function. So for the index from 0 all the way to the length of the given list, and then we make a copy of the given list first. We pop off the ith element from the copy list, and then we catch that by using the a_num, and then we recursively call the function itself by inputting the copy, which is 1 element less, and then we return also a permutation. So let me walk you through an example. For example, this is the starting point. So in this case, nums is equal to 1, 2, 3. I'm just walking through this example over here. And then we also inputting a empty list. The length of the, and then we call the recursor function. The length of the, so now the given list is 1, 2, 3. Perm is an empty list. The length of the given list is not equal to 1. So we go to this for loop here. For I in the range from 0 to the length of the given list, in this case is 3. So 0, 1, and 2. And 0 is the starting point. And then we make a copy of this given list. Right now it's 1, 2, and 3. We pop off the ith element. Right now ith being 0. So a number will be 1. And then we call the recursor copy, which being in this case is 2 and 3, because we pop off the first element. So now we are left with 2 and 3. And perm, in the first case, it was empty list plus a list that containing that number just being popped off, which is 1. So we inputting 2, 3, and 1 to the recursive function back to here. And now the length of the given list is not equal to 1 because it has 2 elements being 2 and 3 in it. And then we throw these 2 and 3 to this for loop I at the beginning equals to 0 and copy this list to be a copy. A number is a copy dot pop off the first element. In this case is 2. So a num is 2 and copy is equal to 3 because the first element being popped off from this list. So in this case, is copy is equal to a list containing a number of 3 and perm plus a num. A num again is 2. Perm is from here, which is 1 from the prior call function. So, and then after we concatenate the two lists will be 1 concatenate the list that containing a num, which is 2. So we are inputting 1 and 2 as the perm in the next call. And then the given list right now is 3. So this condition is met because the given list right now is a list containing a single digit which has a length of 1, and then we append the perm which is 1 and 2, and the given list right now is a list containing a single digit, so we concatenate that. So basically we will be concatenating a list of 1, 2, and 3. So that's the first run for the permutation, and then we do the same thing for this one, the next one, the next one, etc. until we run all the possible permutations. Let's run that. And it works, looks pretty efficient. In terms of the time complexity, it's big O of n times n factorial. So n being we are calling this function n times. Sorry, we are calling this function n factorial time, and each of this function call, the time complexity for each one of this function is big O of n. Because the perm, when the given list it has only one element, when we call this guy, it has n elements in it, and then we are appending it to the answer list. The size of this perm plot concatenate with a given list, the size of that is big O of n. That's why it takes a big O of n runtime to append to the answer list. And the recursive function is being called n factorial time, which is exactly the number of possible permutation. We have to call that many times to generate that many permutations. So for space complexity is n factorial because the answer needs to contain n factorial number of elements. And also this copy list, it has in total n factorial copies because this function being called n factorial times, each time when it's called, a copy is made. And each of a copy, the element in each of the copy is reduced to 1 when it's being recursively called. So essentially, the space complexity of this copy variable, it has n factorial copies, if that makes sense. That's so much for this solution. I hope you like it. If you do, please like this video and consider subscribe to the channel. That will be a huge encouragement to me. Thank you so much for watching this video. Hopefully, I will see you in the next one. Thank you. Bye-bye.